Hi, my name is Amos. I'm from class E1G242 and this is my third video in my engineering maths series. Today, we're going to talk about statistics. To start the video off, I'm going to make reference to an article published by the Straits Times. The title for this article is How much pocket money do Singapore children get from $4 to $14? The reference that I'm going to make to today is the $14, where the Straits Times claims that post-secondary students receive an average allowance of $14. They get these numbers from surveying 500 parents. As you can see, this is a list of statistics where I got from a survey which I have conducted recently. My null hypothesis would be 14, as referenced from this article which I've mentioned in the beginning of the video, where they claim that on average $14 would be received in allowance to post-secondary school students. So my null hypothesis would be 14 and my alt will be not 14. The sample size today would be 35. The sample mean would then, as we calculate from using the Excel formula, 36.77. Then the sample standard deviation, as we also use the Excel formula to calculate, to be 16.515. We will round off to 3dp for this one. Then we will do the test statistics, where we get 36.77 minus 14 over the standard deviation of 16.515 divided by the square root of 35. And we get our test statistics of 8.156. And then we'll calculate the p-value using the Excel formula, and it will equals to 8.15e minus 10. Also, which is equivalent to 8.15 times 10 to the power of minus 10. Why is it so small? I'm glad you asked. This is because our sample mean differs significantly from our claim of $14. We are using the t-test because we do not have the data for the entire post-secondary population. The sample that we are using today is only the sample of students from Temasek Polytechnic. So we do not use the z-test, instead we use the t-test. Now we'll move on to the confidence interval. We're going to bring back our sample size, our sample mean, and our sample standard deviation. Now we're going to calculate our 95% confidence interval, which means our significant levels would be 0.05. To calculate the margin of error, we're going to use the Excel formula to get 5.673. Then we're going to calculate our 90% confidence interval for the population mean. So taking the sample mean, minusing off the margin of error, then we're going to take the sample mean again, and plus the margin of error to have an interval of 31.1 and 42.44. The 95% confidence interval for the true mean allowance for post-secondary students is $31.10 and $42.44. So this is a range where we calculate from our sample, where the students have on average this amount of money for their allowance. The interval does not include the hypothesized mean of $14, which means the Straits Times article is incorrect in this case. However, please take note that this is still a much smaller sample size compared to their sample size of 500. Our sample size is just 35. But in this case, the Straits Times article is incorrect in their statement, suggesting that the true means allowance is significantly higher than $14. In conclusion, our sample differs significantly from the sample claimed by the Straits Times of $14. This is shown when we calculated the p-value of 8.15 times 10 to the power of minus 1, which is significantly lower than our significant level of 5% or 0.05. Therefore, we then reject the null hypothesis of $14 or accept the alt hypothesis of not equals not to $14. Thank you for watching this video, and I hope that you learned something new today. Bye!